This video covers Lesson 2-4 of Secondary 1 Math, Writing and Interpreting Percent Equations in One Variable. One strategy when dealing with problems that have a context that we have to understand, we start by reading what we're being asked to do. So number 1 says write an algebraic expression to represent the cost of the tennis balls before the discount and before shipping. Simplify the expression. So we know we want to write an algebraic expression to represent the cost of the tennis balls before discount and shipping. So we're going to exclude the discount and shipping information. So let's go ahead and read the situation. Andrew is practicing for a tennis tournament and needs more tennis balls. He bought 12 cans of tennis balls online and received a 25% discount. The shipping cost was $5.99 and was not discounted. Let C represent the cost of each can before the discount. So as we read through this, you may have noticed, hopefully you did, he bought 12 cans of tennis balls. So we're going to have a 12 in our expression, our algebraic expression. And he says he received a 25% discount. Now, this is part of what we're not including, right? It was before the discount. The shipping cost was $5.99, but that's also something we're not worried about. And then C represents the cost of each can before the discount. So if we're looking for the cost of the tennis balls, it's going to be 12 times the cost of a can of tennis balls. So 12C. Number 2, write an algebraic expression to represent the cost of the tennis balls with the discount, but before shipping. So here we're going to exclude the shipping part, so we're not worried about shipping. And from number 1, we know that the original cost was 12C. Now, we want to take 25% off, so we're going to decrease, since it's a discount, by 25 hundredths times the original cost, which is 12C's. Or we could write this as what's remaining. If we discounted 25% of the total cost, we would be paying 75%. We could write it as 75 hundredths times 12C's. Either way, we still need to simplify the expression. So looking at the left, if we want to simplify the expression, we're going to take 12C's and we're going to subtract 25 hundredths times 12C's, which is 3C's, which gives us 9C's. Now, if we look to the expression on the right, the 75 hundredths times 12C's, if we just multiply that, we would also get 9C's. So our expression simplified is just 9 times C. Number 3, we're dealing with the same situation. We want to write an algebraic expression to represent the total cost of the tennis balls with the shipping cost and discount, and simplify the expression. Well, if we think back to what we just did in number 2, we ended up with the cost being 9 times C, or 9C's. That's the total cost with the discount. So what we need to do is add the shipping. And if we look back to the problem, it says the shipping cost was $5.99 and was not discounted. So the 25% off doesn't apply to the shipping. So we're just going to add $5.99. And there's our expression that represents the total cost of the tennis balls. Number 4, we're going to actually write an equation to show the total cost is equals $49.19. So we're going to take the expression we have, 9C's plus $5.99, and set it equal to $49.19. Number 5, how much does one can of tennis balls cost before the discount? Well, to do that, we have to solve the equation from number 4. So we'll go ahead, draw our line down, And notice all the variables on one side of our equation, so we're just going to do the opposite of what's happening to our variable. We're multiplying by 9 and then adding $5.99. So we're going to subtract the $5.99 from both sides of our equation. This gives us 9C's, or 9 times C, is equal to $43.20. Next, we're going to do the opposite of multiplying C by 9 and divide by 9 on both sides of our equation. So the cost of one can C is $43.20 divided by 9, or $4.80. And that's the original cost of the can before the discount. Number 6. A jacket is on sale for 15% off its original price. The original price is J. The sale price is $37.40. Write an equation that you could use to find the original price of the jacket. So first we want to represent what's happening here. We have a jacket. It's on sale, so 15% off, so we're going to decrease it by 15%. The original price of the jacket is J. We also know that the sale price is $37.40. So we're going to start out here by saying we got our original, which is J. And what are we going to do to this is we're going to subtract 1500ths, or 15%, of J. And that's going to be equal to $37.40, because that's the sale price. Remember, this is what we did. We found the original price, we subtracted the discount, which gives us the sale price. So this is our equation so that we could find the original price of the jacket. Number 7, David purchased 3 books from Amazon. He received 20% of the original price and paid $5 in shipping. Write an algebraic expression that represents the total cost of the books. Let B represent the cost of one book. So this is key for us to make sure we see this. B represents the cost of one book. So if we're buying books, the cost is B. Well, we can multiply this by the number of books, which is 3. Purchase 3, so 3 times B. Then he received 20% off the original price. So we're going to subtract, because it's 20% off, 20 hundredths, or 2 tenths, times 3B, and paid $5 in shipping, plus 5. Now we want to simplify this a little bit. I mean, this could work as our expression, or we could simplify it by saying, let's see, we have 3 B's, and we have 20%. So instead of taking off 20%, we're actually paying for 80%. We could write it as 0.8, or 8 tenths, times 3B plus 5. Number 8, Becky purchased 6 pairs of socks. She paid 7% in sales tax. Write an algebraic expression to represent the total cost of the socks, including tax. Let the variable P represent the cost of one pair of socks. So to set this up, we have the cost of the socks and sales tax. So we need to find the original cost and then add on the tax. So our cost was for 6 pairs of socks, where P represents the cost of one pair of socks. So we'll get 6 times P. And then we need to add our tax. Tax is 7% of, remember, percent's always of something, so 7% of 6P. So this is one way we can write our expression, or we could write it as 1 7/7 times 6P. Number 9. Kimberly earns $12 per hour after taxes. She saves 15% of all her take-home earnings. Let H represent the number of hours Kimberly works. Write an expression to represent how much Kimberly has saved after H hours. We know Kimberly earns $12 per hour after taxes. So that would be called her take-home earnings. So she's going to get $12 for every hour. Next, we got to say that she's not saving all of those $12 every hour, but she's actually saving 15% of that. So we're going to multiply this by 15/100ths. Now this represents 15% of her take-home earnings after 8 hours. Part B. How many hours will Kimberly have to work to save $117? Write an equation, then solve. Well, to write our equation, we're going to take exactly what we had before, which is the 15/100ths times 12h, and we're going to set it equal to $117 because that's our goal. And we're going to figure out how many hours she's going to have to work to get to reach $117 saved. So we'll go ahead and draw our line down from the equal sign. On the left of our equation, we can actually perform the multiplication. That's 15/100ths times 12h, which gives us 1.8h is equal to 117. Next, we're going to do the opposite of what's happening to h. We're multiplying by 1.8, so we're going to divide by 1.8 on both sides of our equation. And so the number of hours is equal to 117 divided by 1.8, which is 65. So she needs to work 65 hours to save $117. Number 10. James earns $15 per hour. He pays 18% of his earnings to state and federal taxes. His take-home pay for 1 week is $455.10. Let H represent the number of hours James works in 1 week. Write an equation to model James' take-home pay. So our goal is to represent his take-home pay, James's take-home pay. So we know that he earns $15 per hour. So to represent how much he's earning, we would do 15 times the number of hours that he's working, which is represented by H. So 15 times H. We also know that he has to pay 18% of those earnings to state and federal taxes. So we're going to subtract 18%, so 18/100ths, times 15h. And that results in his actual take-home pay. So $455.10. Now we could also write this equation in a different way. Note that we have 18% of his earnings going to state and federal taxes. So think about what percent is he actually taking home? What percent is his take-home pay? Well, it is 100% minus 18%, which would give us 82%. So he's actually taking home 82% of the money he's earning. So we could write this as 82/100ths times 15h equals $455.10. So either of these equations would work. B. How many hours did James work in 1 week? So I'll use the second equation that we came up with in part A and solve it by multiplying 82/100ths times 15h. This multiplication results in 12.3h, which equals 455.10. Now, we're going to do the opposite of what's happening to our variable h. So we're going to divide, since it was multiplying, by 12.3 on both sides of our equation. And so h, or the number of hours he worked in that 1 week, is 37. So we know James worked 37 hours in 1 week. Number 11, Erin purchased 7 concert tickets online. She paid an 8% service charge for buying the tickets online. If her total cost was $170.10, what was the price of each ticket, not including the service charge? Let P represent the price of each ticket. Write an equation to model the situation. So we see above here that Erin purchased 7 concert tickets. So if we're looking at each ticket being the same price, which is represented by P, we'll have 7P. Then she paid an 8% service charge for buying them online. Now, a service charge is something that we're going to increase the cost. So we're going to add 8/100ths of 7P, which results in her total cost, and we see the total cost was $170.10. So we could also write this equation differently. We could write it as, well, what's the total amount that she's paying? She's paying 100% of the cost plus an extra 8%. So we could write it as 1 8/100ths times 7P equals 170.10, or $170.10. Part B, what is the price of one ticket? So now we're going to have to use the equation from Part A and solve it to find the price of one ticket. I'm going to use the second equation that we came up with in Part A, and we're going to multiply 1.08, or 1 8/100ths, times 7P, which gives us 7.56P equals 170.10. Then we're going to divide, since we're multiplying 7.56 to P, we're going to divide by 7.56, or 7 56/100ths, on both sides of our equation. And we end up with P, which is going to be the price of each ticket. So when we divide 170.1 by 7.56, we end up with 22.5, which means each ticket costs $22.50. This concludes the video for Lesson 2-4 of Secondary 1 Math, writing and interpreting percent equations in one variable.